what they need for this, for 4A, ring stand and ring. Triangle. Bunsen burner. Crucible. Lid. Tongs. I have to go because the balances are in there. Use a different scale because that one's all. Crucible. You have to weigh out a small amount of manganese oxide. And they have to fill it with potassium chloride. It says about 2/3, or sorry, it's about 1/3 full. And then this is important, we'll need to catch, they need to mix it together evenly. So you see, you know, a little bit of black and white, you know what happens. So try to get that nice and mixed up. Make sure they get the mass. All right. The mixture in the ring, in the triangle, then put the lid on tilted a little bit so that vapor can escape. Burner on, put it underneath. And then they have to let this heat slowly for a couple of minutes. So heat crucible is at 4. Then regulate heating to room boiler. So the idea is if we take the lid off, you'll see in a second the white powder is going to start decomposing and it's going to release oxygen gas. And what that's going to do is the whole thing's going to change color. It's going to be more of a darker gray, not black, with a little bit of purple tinge to it. And basically, once they have this going, they just let it heat for about 15 minutes, and then let it cool down, and then they measure the mass. So I'll let this, yeah, so if you can see the vapor coming off a little bit, I'll take the lid off. starting to kind of cook around the outside. Right?
Mm-hmm.
So they need to basically let it cook all the way through. Flame kind of coming in contact with the bottom of the ceramic crucible. And the wood is all treated, so it's not gonna, it might singe, but it's not gonna burn. And they just have to check it repeatedly, like I said, for about 15 minutes. That's part 4A. It's copper sulfate. And they're gonna heat it as well.
4B.
Yep. So they need, and I think we use these for 3. So they need the stand, the gauze in an evaporating dish, Bunsen burner, and striker. So they have to measure out. Watch these. So again, they have to measure out some of this, 5 grams. That's at 48 something. About 5 grams.
I love that blue.
Is blue. Yeah, and so once they have that on here, they just start a flame. Much like they did before. That way. And they're going to basically heat this. Again, that's going to take some time, 15, 20 minutes. And we'll come back and take a look at it after a while so you can see what the change is. Notice how it's kind of more charred, kind of grayish. And I never really know a good visual point to say this is supposed to be done. So I say once it changes color and stops changing color, give it another 5 minutes. And that's because the crystals have water trapped in them, so we're evaporating out the water. Of each of these different salts. And this is one where I think you're gonna need to like illustrate how much they need. Like
Okay.
a pipette tip's worth at most, which fills up about that much of the test tube. Sorry, I'm ripping it away. Because a problem I have notoriously is that they fill up like
Too much.
that much.
Oh,
One,
my.
you're wasting time, you're wasting material and wasting time. And it directs them to, but how much to take, but not the directions that closely. And then the thing we're going to do with this one is we're just going to heat each of these salts, each of these crystals, and see what happens when we do. So the students write down what happens. So they write down what happens. If you look at this one now, you notice how it's on the outside where it's heating. You see it's turning gray. So this they have to. Well, they'd have to get it all the way down to that. So they're literally evaporating it. So you don't want to do it like this because they lose material, but. So for this, they just need the test tubes and these test tube holders. And if I take one, and so what you're gonna see, if you look on the inside of the test tube, you see how there's that, I put it in and it heats it and immediately you start seeing condensation on the inside? Okay. So the fact that it's condensing, and if I heat this one for a little while, look, it's even sort of melting the water out. So this compound is like the copper sulfate. It has a lot of water trapped in the crystal. Like it's not, students will look at this and say, oh, it's melting. It's not actually melting. It's that the water that's in the solid is coming out. Yeah. So what they check to see if anything happens, and they don't, that one had a little bit of condensation. And what they need, if they don't see anything right away, that's all. It is almost instantaneous. And this one you'll see, okay, you get some of that, but also once it heats up a little bit, right, you can hear the water. Notice it's changing color, it's becoming more red. Okay. So if they see a color change, and these last two are the ones that are going to change the most. So this one, okay, you're getting that condensation being made. Notice it's starting to turn like kind of royal blue. It's a blue. I know it looks kind of black and white, but a little bit more. You see, oh, it turned that color.
Purple.
Definitely not the color it was before. I mean, this one should turn yellow. You can see it around the edges, right? Turning yellow. I'm just gonna let that one go all the way.
How long are you gonna hold that?
Honestly, just to get more of that color.
Okay.
And the reason is the last bit of instruction that they have is that anything that changed color, should be at those ones. The last thing they have, the last thing they have to do with those is add a little bit of water back to it. You know,
Yellow,
greenish,
blue.
and it turns yellow. And we ask, can we turn it back if we rehydrate it? Okay. And you do it with the other ones. Does this go back to that more kind of that color purple? Right. And then this one. That color change back. And it goes back to that more like day glow orange.
Yeah.
And that's all they have to do for that last one. Okay. You know, that kind of grayish, tannish, that's the fully dehydrated form. Anhydrous is the term. But once this is done, and we'll pretend it's done. Once that's done, they let it cool off until they can hold it. And then they'll measure the mass. I'm just gonna put this on the, you're gonna measure the mass and they'll see that it's lost, you know, the water that was in there evaporated off, so it's not as much mass in there. And they can use that to calculate how much water is in the crystals, the formula of the crystal. Let it cool down and measure the mass. And once they've measured the mass, they have to do calculations, and that's that. With this one, they're going to rehydrate it as well, but first they need to change it. So it'll have cooled down all the way, but they need to kind of get the idea of the temperature of the compound that's in there. And if you look at the thermometer, okay, so it's like 25 degrees. Once they add water in, right, the temperature heats up substantially. And the reason for that is, and it goes back to its original color, and that's because the molecule, when it's rehydrating, when the water's going back in, that's exothermic. It causes heat to be released. So you see the temperature was kind of between 20 and 30, and then immediately went up to like 45. And that's not because the ceramic is hot, it's because of the heat from the